This case started with a phone call I'll never forget. "Hey Ray, my boiler's making a weird moaning sound, like a cat in heat," the maintenance tech said. Now I've heard banging, rumbling, ticking, but this piqued my curiosity. I had to know what caused the noise. I thought you would be surprised at the cause. Welcome to Boiler Room Detective. I'm your host, Ray Wohlfarth. My 14 boiler books are available at T.F. Campbell, Pronto Heating Supplies, Amazon, and heatinghelp.com. Arriving at the building, I headed down to the boiler room and I heard the noise right away, a loud moaning sound when the burner fired. To me, it sounded like an orca whale. Not normal, not even close. This was a copper finned boiler, and that noise was a warning sign. Looking around, circulator running, burner firing, but something didn't feel right. I checked the temperatures. The supply temperature was climbing fast, but the return wasn't keeping up. The delta T kept getting wider, over 60 degrees when I turned off the boiler. Most boilers want a 20 to 30 degree rise through the boiler. That's when I thought wide delta T, or temperature rise, means low flow. Walking around the boiler room, I stopped when I saw it. The flow switch, cover missing, and a jumper across the terminals. I turned to the tech and asked, "This your handiwork?" "Yeah, the boiler kept shutting off. I figured the switch was bad. I didn't think it was a big deal. There's a low water cutoff." The flow switch doesn't just protect against low water, it also catches pump failure, closed isolation valves, airlocked pipes, clogged strainers, or frozen pipes, anything that stops circulation. Proper flow is absolutely paramount to a boiler like this. In this case, the low water cutoff verified there was water in the boiler, but didn't know it was flashing to steam, causing the moaning sound. The heat exchanger was cooking itself. And this is where a lot of people get it wrong. The low water cutoff protects the boiler from a lack of water. The flow switch protects it from a lack of flow. You can have a boiler full of water, but if it's not moving, the heat exchanger can overheat and destroy itself. Here's how a flow switch works. There's a paddle that sits inside the pipe. When the proper amount of water flows, it pushes that paddle, which closes a set of contacts. That tells the boiler, "We've got flow, it's safe to fire." If it stops, the paddle drops, the switch opens, and the burner shuts off. Simple, reliable, critical, unless someone jumps it out. So now we've got a boiler firing with no idea if water is actually moving. The cause? A clogged strainer. The pump was running, but the flow was restricted. So the heat had nowhere to go. We cleaned the strainer. Immediately, the noise disappeared. We replaced the flow switch as it was original to the 10-year-old boiler. The manufacturer recommends replacing the flow switch every 5 years or 100,000 cycles. We installed the correct paddle for the pipe. Too long, it drags on the piping. Too short, it won't trip the switch. We tested the new flow switch when done. Circulator starts, water moves, paddle shifts, click, then the burner fires. Smooth, quiet, and normal. I showed him how to maintain it. Once a year, you shut the system down, remove the switch. Remember, the pipes are going to be full of water. Inspect the paddle. Look for scale, wear, or buildup in the pipe. Make sure it moves freely. Reinstall and test it. I like to shut off the pump to make sure the burner won't fire when testing a flow switch. That's how you know it's doing its job. Boilers don't just fail out of nowhere. They almost always give you a warning first, if you know what to listen to. So next time you're in a boiler room and you hear something unusual, don't ignore it. I'm Ray Wohlfarth, and this is Boiler Room Detective, and I'll see you on the next case.